Morning, everyone. Today we are going to start probability. We will little bit discuss its formulas and what is the definition of probability, what is random experiment, what is sample space, what is independent events. Okay. Then we will see little bit about diagrams, Venn diagrams. Then we will see what is the complement of event. Then we will do questions. So main focus will be on questions only uh, that you might be aware with the concepts already. Let's start. So we will start with the definition of random experiment. So basically, here it is written that an experiment in which total outcomes are known in advance, but occurrence of a specific outcome can be told only after the completion of experiment. This is called random experiment. Okay, so suppose let me give an example of what is random experiment, what is random experiment, what is not random. So basically, suppose करो आप सुबह when you wake up in the morning, you say that it might get rain today, कि आज बारिश हो सकती है. Okay, so it might rain today. You have just make the guess. तो हो सकता है बारिश हो सकता है बारिश नहीं भी हो. एंड वही अगर आप ये गैस लगाते हो, दूसरा गैस सपोज आप लगाते हो कि टुडे सन विल राइज इन द ईस्ट. तो आपने दो गैस किए. पहला गैस किया सपोज आज बारिश हो सकती है, दूसरा आपने गैस किया कि सन जो है आज ईस्ट में राइज करेगा. तो अब आप सोचो कि पहला जो एक्सपेरिमेंट है, पहला जो आपका इवेंट है, ये हो भी सकता है और नहीं भी हो सकता. दूसरा इवेंट है कि सन विल राइज द ईस्ट. अब इसमें से आप बिफोर हैपनिंग ऑफ द इवेंट क्या आप कह सकते हो कि ये इवेंट होगा ही होगा? बिल्कुल कह सकते हो. किसके बारे में? इसके बारे में. क्योंकि हमको पता है सन ऑलवेज राइज इन द ईस्ट. तो इसका मतलब एक्सपेरिमेंट इवेंट होने से पहले ही हमको पता है कि ये ईस्ट में राइज होगा, और ये इसका मतलब ये एक रैंडम एक्सपेरिमेंट नहीं. Okay, so we already know that the sun will rise in the east before completion of the event, before rising of the sun. So that's why it is not a random. But in first case, there might rain today. It means that rain हो भी सकती है, नहीं भी हो सकती. ये तो तभी पता चलेगा जब आज का दिन कंप्लीट हो जाएगा. अगर बारिश हुई होगी तो आपका गैस सही था, अगर बारिश नहीं हुई होगी तो आपका गैस गलत था. It means that random experiment is big in which you can say about its occurrence after its completion. Okay. जैसे यहाँ पे एग्जांपल दिया है, टॉसिंग अ कॉइन. कॉइन अगर आप टॉस करते हो तो यू नो व्हाट इज द आउटकम. इट माइट बी हेड, इट माइट बी टेल. एंड बिफोर टॉसिंग यू कैन नॉट से इट विल बी हेड, इट विल बी टेल. ओके, इट कैन सपोज यू सेड इट इज हेड बट इट कैन कम टेल. दिस इज व्हाट वी कॉल अ रैंडम एक्सपेरिमेंट. नाउ what is sample space? Sample space is basically total possibility of a random. Okay. So suppose in it might rain today. Here, what were the total possibilities? Yes, it can rain today or it cannot rain today. So there were two possibilities, yes and no. But here, this was not even a random experiment, so we cannot talk of the possibility. In tossing a coin, what will be the sample space for tossing a coin? It will be head or tail. Suppose we toss a dice, then what will be the sample space? It can come one, two, three, whatever it can come. So this is the sample. Suppose we toss two coins. So in case of two coins, how we will calculate the sample space? Suppose this is head, this is tail. Write head and tail here as well. Okay. So it depends on the number of coins. In the first case, it is HH, then it is HT, then TH, then TT. So header, there can be two heads, one head and one tail and one head and two tails. Okay, so this is a sample space of two coins. Similarly, you can calculate the sample space of two dice. All right. So now let's discuss the definition of probability. So basically, what probability is? It is certainty. It is the measurement of certainty of a event, that it can, how certain it is the event that it can happen, or how certain it cannot happen. Okay. So basically, we can say the number of favorable case to an event upon total number. How much are the favorable that we want? Suppose we want in tossing of a coin, we want head. then number of cases, there can be two cases, head or tail. The number of cases that we want is 1, and total number of cases is 2. So it means that probability of coming ahead is 1 by 2, right? So always remember, if the probability of happening of an event is P, then the probability of non-happening of the event denoted by P bar is equal to 1 minus, or sometimes it is denoted by Q as well. Okay, so when an event is happen and its probability is P, then the probability of not happening of an event is 1 minus. And one more thing, always remember that the probability will always lie between 0 to 1. It will lie in the interval, close interval 0, 1. If the probability is 0, then the event cannot happen. If the probability is 1, then the event will always happen. Okay. So first case it is called impossible event, and second case it is called certain. Okay. Next, let's come to the another definition. This is independent event. Independent events are the events in which the happening of one event does not affect the happening of other events. Suppose one event is happening and the other event is not happening, then it does not matter whether the event A, suppose we have two events A and B. If A is occurring, then it will not affect whether B will occur or not. For example, there are 4 red and 5 green balls. A is the first event that one green ball is drawn, and B is the second ball that a red ball is drawn. Then, whenever one red ball is, whenever a green ball is drawn, it does not affect that a second ball drawn will be red or not. Okay, so it will not affect the certainty of happening second event. So this is how we can. Once we do the question, you will get more clarity on the definition of independent. All right. Next, let's we see some example of Venn diagram that we already seen in. Okay, sets. Had I told you the sets? I don't remember. Did we study set or not? We studied Venn diagram before. Uh, okay, okay. So Venn diagram is, suppose this is an event A, this is an event B, then we can represent them by diagram, and this is the sample space S. Then we can represent the events probability as a diagram or events completely as a diagram. So this is event A, this is event B. Then the part that coming in the intersection is called the A intersection B, and the complete part of this is called A union B. Okay, and the part outside A is A complement, and part outside B is B complement, and part outside both of these union A complement B complement is A union B complement. Okay, so there are some definitions, and A intersection B is also written as A. Okay, so this is something that it is that you should know. Okay, the probability of A complement. These are some formulas you can remember. A complement intersection B complement is equal to 1 minus probability of A union. Similarly, probability of A complement B is probability of B minus probability of A intersection B. Probability of A B complement is C, probability of A minus probability of A intersection B. All right. Now let's see what is complement of event. So suppose there is a sample space X. Okay, and event A has 5 outcomes, 4 outcomes, say 1, 3, 5, and 6. 1, 3, 5, and 6. Then happening of event A will depend on these numbers 1, 3, 5, and 6. So not happening an event is the sample space minus A. Okay, so sample space में से आपको A minus कर देना है. You need to subtract A from whole of the sample space that you will be got those elements which are not in it. Okay, so basically not in it. So this is nothing but 2 common. And always remember, A complement union A is always simple. Uh, is this portion important for AFCAT? Yeah, questions somehow came in AFCAT as well from probability. So not frequently, but yeah, questions come. Not, I will not cover. See, you will not see a lot of tough questions or very hard questions. Always there will be easy question in that portion of it. So we will do the questions that are and always from probability section question came that is only 2 or 3 lines, not more than that. That can hardly be of 4 lines, not more than that. Okay, so questions are coming like that. Easy questions, they come. Some. It is important to cover the section as well because it is not tough. The marks of probability are free to get. If concepts are, see, this is the only limited number of concepts and formulas. Just apply them and you get down. Okay, so let's start with some examples. So there is a class of 125 students, 70 passed in mathematics, 55 passed in statistics, and 30 passed in. Okay, so let me tell you some formulas, some more formulas that I have put here. Suppose there are two sets A and B having some number of elements in it. Then always remember n of A union B is equal to NA plus NV minus NA. Then, okay, this formula. So from here you can conclude that probability of A union B, this implies the fact that probability of A union B is probability of A plus probability of B minus probability of A intersection. Okay. So next is De Morgan's law. So it says that A union B complement is uh, n of uh, n of A union B complement n of S minus n of A intersection. Similarly, n of A intersection B complement is equal to n of S minus n of A union B. Okay. S means number sample space. Sample space is also a set. This is also a set. But I am not teaching probability over here on the basis of sets because probability is always defined on sets. So here, if I go into the complete definitions and all the concepts that are taught in NDA or higher classes that you might not be familiar with, then all the events are the subsets of sets. Then you get to know what is sets, what is subsets, and all these. And so here, you do not need all these things. You just need the simple definition and formula, and you will explain. And n, suppose E is a set, then n of E represents number of elements in E. That's simply okay. So n of A union B complements means number of elements in n of in A union B, and n of S means number of elements in sample space. Okay. So these are formulas. So in first case, in first question, in a class of 125 students, so it means that S is 120. 70 passed in mathematics, n of S. 70 passed in mathematics, it means that number of students passed in mathematics is 450, 70, 70. 55 passed in statistics. So statistics, suppose I represent it by T. Okay. Then number of students passed in statistics is 55. And 2 passed in both. So it means that in its maths and statistics both. So it means in common. So I told you na the common portion is this. This is A intersection B. Okay, so the common portion means passed in maths and statistics both. So these are 30. So what it is asking, what is the probability that students selected at random from this class has passed? What is the probability that the selected student? What is the probability that a student selected at random from the class has passed in only one subject? It means that if he is passed in maths, then he is failed in maths for statistics. And if he is passed in statistics, then he has failed in. So this is the case of this formula. Okay, so and whatever thing is in not in complement, you need to subtract it from here. So it is n of m minus n of m intersection t plus n of t minus n of m intersection t. So it is n of m, you know, it is 70 minus n m intersection t, it is 30 plus n of t, it is 55 minus 30 again. So it is 125 minus 60, it is 65. Okay, so favorable number of favorable outcomes are 55, and total we know that it is 125. So probability will be 65 upon 120. Bar means complement. This I told you now, denoted by a bar, a complement, or AC. Complement of union. Okay. What's this? I have specified over here na a complement or a bar is sample space minus a. Remove the elements of a from the sample space, then it is a bar or a complement. These are notations only. You can write it as a bar, so a dash, a bar, or a complement. This symbol, this is simply dash, nothing. This is all these symbols. It is dash, it is bar, and it is c. It is all these complement on. What do you want to know? I am not understanding. This is also, see, these all, whether you write this or this, all symbols are called complete. All symbols means complement only. You can call this as bar, call this as dash, call this as c. No problem. Yeah, these all are complements. These are same things. You can apply any of these. You can write any of them. It is not like a bar means something else, a dash means something else, or AC means something. No, no, they all means complements. Okay, so you have the favorable outcomes, you have the total outcomes. So this is how you calculate the probability. Anmol, please put yourself. Okay, next question, option number A, 65 upon 25. You can cancel it out by 13 upon 20. Okay, so option number A. Now let's move to next question. A dice is thrown, the probability that a number greater than 4 may appear at the dice. So sample space when the dice is thrown is 1 to 6. Number of elements in sample space is 6. So number greater than 4 and favorable outcomes is 5 and 6 only. So uh, probability will be favorable outcomes upon total outcomes. So NE upon NS is 6 upon, oh, sorry, 2 upon 6. So it is 1 upon 6. This is very easy question. Okay. So answer is option number. Next, 3 dice are thrown. Okay. Let me write a formula. Number of elements in sample space. This is the formula. You need not to calculate every time. When first n coins are tossed, so number of elements in sample space will be raised to power n. Or it can either be written that n coins are tossed, or it can be written like a coin is tossed n times, then the sample space will remain same. N dice are thrown, then the number of elements will be 6 raised to power. Which screen I have rubbed? No, no, I have not rubbed. You want to write this? You can write it. Have you written it? There was nothing so much hard in this question that you solve by giving you time. Okay. So number of elements in sample space when n coins are tossed is 2 raised to power n, and number of elements in sample space when n dice are thrown is 6 raised to. Okay, or n times dice. Okay, so it is really same in either way. 3 dice are thrown. What is the probability that same number will appear on each of them? Wait, some. Okay, so next is okay. We need to find probability that the same number will appear on each of them. So dices are 3. So it can be same number on each of the dice. It means 1 on each of the dice, 2 on each of the dice, 3 on each of the dice, 4 and so on, 6 on each of the dice. It means that 1, 1, 1, 2, 2, 2, 3, 3, 3, 4, 4, 4, and 6, 6, 6, 6. Okay. So probability will be number of favorable outcomes upon number of total outcomes. So we know that number of favorable outcomes will be 6 only, and number of favorable outcomes will be how much? Now 3 dice are thrown, it means 6 power 3. So which is equal to 6 upon 6 into 6 into 6. You can cancel out 1 6, will be 1 upon. So option number B, which is correct. Okay. Any doubt? All right. Okay. Now let's move on to another question. 3 coins are tossed together. Now, since 3 coins are tossed, tell me the number of elements in sample space. Tell, write in the chat box, or you can tell by unmuting as well. 3 coins are tossed together, then the number of elements in sample space will be. Just apply the formula that I told you. 2 raised to power 3. Very good, Sibram. I told you na here, number of elements in sample space when n coins are tossed is 2 raised to power n. So here n is 3. So the number of elements in sample space is 2 raised to power 3, which is 8. So probability of getting at least one head means, okay, so at least one head means, so sometimes suppose our number of elements in favorable outcomes are more than the number of elements in that are not favorable to us. So in that situation, what we do, we find the probability of not happening the event and subtract it by 1, then we will get our probability. So 3 coins are tossed in the probability of getting at least one head. It means that probability is equal to probability of getting at least one head is equal to 1 minus probability of getting no head. So if we do not get any head, it means that um, there will be all tails. So there is only one situation in which you can get all tails is TTP. So this is the only situation. It means that probability of not happening an event is 1 upon 8. So 1 minus 1 upon 8 is 7 upon 8. That's the answer. Okay. So this is the same formula that I have told you. Let me bring it on. where it was. This is probability of non-occurrence of an event is PE is equal to 1 minus PE. So you can take PE this side and bring E bar this side. Okay. This is the same formula that I use. So that the three coins are tossed together, then the probability of getting at least one head is 7 upon. Okay. Now let's move to another question. One card is drawn randomly from pack of 52 cards. Then the probability that it is a king or a spade. So let me tell you about cards. There are cards are of two different colors. One is red and one is black. Okay. So there are total 52 cards. Okay. So red are 26 and black are 26. So in red, there are two different cards, diamond and heart. Okay, diamonds and heart. In black, there are two different cards, club and spade. So in each of these diamonds or heart or spades, there are 13 different cards. 13, 13, 13, and 13. Okay. So in these 13 cards, they are labeled from A, which is ace. Okay, which is denoted by A, then one, then two, then three, and so on. It goes up till 10. After 10, there is a card marked J, a card marked Q, and a card marked K. So K is king, Q is queen, J for jack, and 10 is 10, and you know the rest. Okay. So it means that in each of these cards, there are in each of the 52 cards, there are four A's, four twos, four threes, and everything is four. Four kings, four queens, four jacks, and four tens. Everything will be four times in all of the 52 cards. Okay, so now let's focus on the question, what it is saying to us. One card is drawn randomly from the pack of 52 cards. So number of favorable outcomes is one only. Okay, then the probability that it is king or, oh, sorry, not, it is not one. It is one card is drawn. Then the probability that it is king or spade. So it is king. So how many kings are there? There are four kings. Okay. Plus he is saying it can be spade also. So how many spades are there? There are total of 13 spades. There are four kings and 13 spades. Now focus. In spade, there will be one king as well. In spade, there will be one king as well. And we are adding four kings. It means that we already added the king of spade because we have one king of diamond, one king of heart, one king of club, and one king of spade. So we have already added the king of spade. It means that whenever I am adding the number of spades, I need to subtract that king because we have already that. We have already added that. So it means this is 60. Okay, so number of favorable outcomes is 16, number of total outcomes is 52. So probability will be 16 upon 52. So it is 4 upon 30. Okay, so option number C. Next question. From a pack of 52 cards, two cards are drawn in succession one by one without replacement. The probability that both are aces. So you do you know the concept of permutations? NCR, permutation and combination. Do you know this? NCR means what it does mean? Do you know this or not? Tell me. So it is n factorial upon r factorial upon n minus r. What is this? Is what NCR? Okay, but it so if it is written 3 CR, it means this 3C2, it means this 3 factorial is divided by 2 factorial and 1 factorial. So 3 factorial, what does mean by a factorial? N factorial means n multiplied by n minus 1 and so on up to 1. Okay, so if it is written 5 factorial, then it means that 5 into 4 into 3 into 2 into 1. Okay, so this is what factorial means. So sometimes when the number is coming out too large, we use the concept of factorial. Okay, so selecting NCR means choosing R uh, elements or objects out of n objects. Suppose you have n objects and you want to choose R object from that, then the base you can select is NCR. This is what NCR represents. Okay. So in our case, we have a pack of 52 cards. 2 cards are drawn in succession one by one without replacement. So in the first case, that both are aces. So how many aces are there? There are 4 aces. Okay, total 4 aces that I have told you here. Ace. There are 4 aces, na? So in first case, we can bring out 4 aces. So it will be okay. One more thing that I can tell you. So this question you can do by using NCR also or not using NCR. I am telling you one more concept. See, suppose you are dealing with finding two probabilities, combining them together to find a single probability. So it can be asked in question in two ways, and or. Okay, so it can be asked in two ways. One can be and one can be or. So whenever it is of the form and, you will multiply. Okay, and whenever it is of the form or, you will add. So in the first case, the probability that both are aces, it means first is and second is. So for the first state, we know that probability will be 4 upon 52 and second is. Now in case of and, how many? See, one spade is came out. So it is not being replacement. So it means that there are only 3 aces now. The number of aces is 3, and also the number of cards is now reduced to 51 only. So this is how you can calculate uh, by using two different probability in scenario of and or. Suppose it has been asked or, if it is coming in between, instead of and, it is coming to be or, then you will add them together. Okay, so this will be the probability. You can multiply it. So what it will come when you multiply it? It is 12 and 52 into 51. You can tell me what it will come. 52 into 51, what it will be? 5, 10, 15. And 25. So it will be 2652. No, 25. नहीं, 52 into 2652. 15, 5 and 5 are 20, 25 and 126. Okay, 265. From a pack of 52 cards, 2 cards are drawn. The probability that both are equal. I think it is correct. What is the answer? Now we need to cancel out 12 to 260. Is it dividing it or not? It might divide. Let me divide 2, 6, 5, 2 divided by 12. So it will be 221. Okay. The probability will be 1 upon 2 to 1. Okay. Now let's move to second question. This is direction type question. A and B are two non-mutually exclusive events. probability of A is 1 by 4, probability of B is 2 by 5, probability of A union B is 1 by 2. And this is what is given to us. Okay, this is what is given. So we need to find first A probability of A intersection B. Okay, so we know that probability of A union B is what? Probability of A plus probability of B minus probability of A union B. Okay, so probability of A is given to us as 1 by 4. Probability of B is given to us as 2 by 5. Of probability of A union B, sorry, A intersection we will find here. Probability of A intersection will be, it is, okay, we have A union B. So it is 1 upon 2. And we do not know the probability of A intersection. So it means that probability of A intersection B is 1 upon 4 plus 2 upon 5 minus 1 upon. So you can take the LCM, it is 20. Okay, 5 plus 8 minus 10. So it is 3 upon 20. So this will be the answer. So we have applied the formula probability of A union B is this, and we just put the value over here. So from here you can see that if probability of A is 1 by 4, then probability of A dash or A bar is equal to 1 minus 1 by 4. I am just telling, it is not being asked. Maybe it can be asked further. Similarly, probability of P naught is equal to 1 minus 2 upon 5, which is 3 upon 5. And probability of A union B complement, it will be 1 minus 1 upon 2, which is 1 upon 12. Okay, so this is how you can calculate the probability of A naught, B naught, and anything else. So first question is solved. Now let's check the answer. It is 3 upon 12. Next question, what is the probability of A intersection B naught? So again, we will apply this formula. Where is the formula? This. We will apply this formula again. Probability of A intersection B naught. It is probability of A minus probability of A intersection B. Okay. So formula you need not to recite them. Just do the questions. You will get to know each and every formula. So it is asking for probability of A intersection B naught, which means that probability of A minus probability of A intersection. Okay. Okay, so if I started to tell you, so there is a reason, there is a proof that how this formula is coming like this, but the proof is in class 11th or 12th in the NDA section. So if I started telling you the proof, what is tomorrow's topic? You can see in the schedule, I don't remember what it is. It might be number system or I don't know. It can be number system. Okay. So A intersection B naught is probability of A minus probability of A intersection B. Probability of A is given to be 1 upon 4. And probability of A intersection B is 3 upon 20. Multiply it by 5, then you can subtract 5 minus 3 upon 20. So it is 2 upon 20, which is 1 upon 10. Okay, so you need to just apply formulas and answer will come. The next question. What is the probability that in a family of 4 children, there will be at least one boy? Okay, so there are 4 children in a family. So we need to find at least one boy over there. So suppose suppose let me tell you the concept of solving these questions. So suppose there is only one children in a family. One children in a family, then it can be boy or girl. Right? Suppose there are 2 children in a family, then it can be first uh, first can be boy and second can be boy. First can be boy and second can be girl, and first can be girl and second can be boy, or both girls. So this is the Okay, you are giving answer 15 upon 16. Okay, let's check. We will test. So suppose there are three, then we will again find the sample space. So you can see one thing. There are two possibilities. So in case of two possibilities, this question is analogous to finding the to dealing the sample space of head and tail. So I already told you tossing the coin n times, or there are n coin toss, then there will be the number of elements in sample space will be 2 raised to power n. So it is valid to each of that event that has only two outcomes. So in this case also, if we compare it with the experiment of coin, then in this case also the number of elements in sample space will be 2 raised to power n is 4. So it is 2 raised to power 4, which is 60. And it is saying at least one boy. So probability of at least one boy is 1 minus probability of no boys. So if there is no boy in a family, it means all girls are there. So all girls means 4 girls are there in the family, then there is no boy. So it means that there is only one possibility of getting all the girls. This is G, 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 and G. So every other event will contain at least one boy. So how many total elements? There are 16. How many girls possibility of getting all the girls is one only. So 1 upon 16 is being subtracted from 1. So it is 15 upon 16. So very good. Okay. So this is the question. That is analogously you can relate the question. All right. So there is A only. Next question. What is the probability of having 53 Sundays or 53 Mondays in a leap year? This is very easy question, and this question you can encounter several times. So in a leap year, so how many number of days in a leap year are? How many number of days in a leap year? There is 366 days. Right or wrong? Right? Okay. So now there are total number of 52 weeks. So it means that 52 into 7, it is 364. It means 360 in 364 days. There there have been 52 Sundays and 52 Mondays. Now we have left with 2 days only. We have already done with the concept. We have already done with the problem of 364 days. Now we only have to worry about next 2 days. So suppose there are 2 days are coming after 364 days, then the days will be of what form? Monday or Tuesday, then Tuesday or Wednesday, Wednesday or Thursday, Thursday or Friday, Friday or Saturday, and Saturday or Sunday, and then Sunday or Monday. Okay, so how many possibilities of their two consecutive days are? 1, 2, 3, 4, 5, 6, 7. Monday, Tuesday, Tuesday, Wednesday, Wednesday, Thursday, Thursday, Friday, Friday, Saturday, Saturday, Sunday, and Sunday. So there are the only possibilities of two. Yeah. I tried 366 only. Okay. So it is saying 53 Sundays or 53 Mondays. So it means that here it is or. Remember, 53 Sundays or 53 Mondays in a year. Okay. So if there are already 52 Sundays and 52 Mondays. So Monday can come in this situation, but then there will not Sunday. Or Sunday can come in this situation, right? Or Sunday can become this situation. So how many times Monday or Sunday is coming? It is 3 times. Either with Tuesday, either Sunday with Saturday, or either Sunday and Monday together. So in this case, what is the possibility? 1 upon 7. There are total 7 events now. 1 upon 7 plus 1 upon 7, which is 3 upon 7. So that's all. It is or. So that's why we added. In case of and, we will multiply. Here it is written or. So that's why we have added all the three possibilities. So it is 3 upon 7. So option number B is correct. Okay. Any problem? Sample space of last 2 days. Okay. A coin is tossed 4 times. The probability that at least one head turns up. So you have already did this question in form of boys and girls. Okay, so I am giving this as homework. It is answer will be the same. Okay, next question is that a husband and wife appear in an interview. Okay. Okay, husband and wife appear in an interview for 2 vacancies in the same post. The probability of husband selection is 1 upon 5. Wife selection is 1 upon 3. What is the probability that one of them will be selected? So you can try this easy question. Now you can try. Now I have already told you a lot of examples. Now we are starting with the question. I will give you time for that to do those questions also. So try to do this question and tell me the answer. Question is asking only, let me give you a hint, only one of them will be selected. It means that if husband is selected, then wife will not selected. Not means complement. If wife will selected, husband or wife, so it means that plus will come in between. It is not husband and wife, it is coming husband or wife. So probability, if husband is selected, then wife will not be selected. If wife is being selected, then will husband will not be selected. Okay, husband is selected and wife is not. So and is coming in between, so we have a multiplier. Or wife is selected and husband is not selecting. So again and is coming in between, so we have multiplied. So whenever there is and, you will multiply. Whenever there is or, you will add. Okay, husband and wife or wife and husband. So there are two possibilities now. In case of or, we have added. In case of and, we have multiplied. Okay. So you now know that probability of husband selection is 1 upon 5 and probability of husband's not selection is 1 minus 1 upon 5, which is 4 upon 5. Probability of wife selection is, we know that, so probability of not wife selection is 2 upon 3. So 2 upon 3 plus wife selection is 1 upon 3 multiplied by 4 upon. So it is 2 upon 15 plus 4 upon 15. It is 6 upon 15. 2 upon 5. Okay. So who has given the answer? Sigram, yes, it is correct. Very good. So option number B is correct. Next question. Our bag contains 5 balls, 5 black balls. The number of black balls is 5. Number of white balls is 4. Number of red balls is. If a ball is selected at random, the probability that it is black or red. Remember what is this thing? It is black or red. So how many black balls are there? 5. The probability of selecting one black ball is 5 upon how many total balls? Total balls is 5 plus 4 plus 3. So it is 12. Yeah, it is 12. So probability of selection of black ball is 5 upon 12. Probability of selection of which ball? A red ball. Red ball is, how many red balls are there? 3 upon 12. So it is saying black or red. So it means that we will add them together. That says 5 upon 12 plus 3 upon 12. So it is 8 upon 12. Cancel it out 4, 2 upon 12. This is option number 2. Okay, this is easy question. You can also do it by using permutations. Okay, but here the number is not too much big, so that's why we didn't use permutation. You can do like this. Uh, 5C1 plus red is 3C1. One is selected from 5 and one is selected from 3. And 12C1. One is selected out of 12. So you can do it like this also. So in this case, it will be 5, it will be 3, and it will be 12. So 8 upon 12. You can answer 2 upon 2. Okay, so by using permutations, you can also. Okay, so option number D is correct. Now move on to next question. This here the number, see, now the number is bigger, 52. So here we can use the concept of permutation combination that will make our life easy. Okay, the probability of having a king and a queen. He needs king and a queen when two cards are drawn at random from pack of 52 cards. So here it is and. Okay, so now what we have to do, okay, first is king. So it means that how many kings are there? 4 kings. And uh, one king is selected from 4. Okay. How many queens are there? 4. And one queen is selected out of 4. So how many total cards are selected? 2 cards. Okay. So 52 cards are selected out of 52. This is how we do 4C1 into 4C1 divided by 52C2. So number of favorable upon number of total. Upon number of total. Okay. So this is the probability. So we know that what is 4C1? It is 4 factorial upon 3 factorial, 3 factorial multiplied by 4 factorial upon 3 factorial, 1 factorial upon 52 factorial divided by 50 factorial and 2 factorial. Okay, so the first case it will be 4, 4 divided by 3, it will be cancelled out, it will be 4, it will be 4. 52, it will be 52 into 51 divided by 2. Okay, so it is 4 into 4. So it is 2, 26, 26 into 51. So 26, 16 upon 26 into 51, it will be, how much it will be? 26, 1 ja 26, carry 2. 26 5 ja 130. So 130 and 2, 132, if I'm not wrong. And you cancel it by 2, you cancel it by 6, 6, 3. So it will be 8, sorry, 2, 8, yeah. So it will be 8 upon 6, 6. This is option number B. Okay, so this was also good question. All right. So let's check the answer. It is. Have you written everyone? Okay. Next question is saying that two balls are selected from a box containing 2 blue and 7 red balls. Number of blue balls is 2. Number of red balls is 7. 2 balls is drawn. So what is the probability of at least one ball is blue? It is not saying. It is saying that at least one ball should be blue. Okay, so it means that probability of at least, so how many blue balls can come? At most 2. So it means probability of one blue ball plus probability of 2 blue balls. So it was at least one ना, so एक भी आ सकती है या फिर दो भी आ सकती है. It means 1 or 2. So here or in between, so that's why we have used plus. So if it was and, then we would have multiplied. Okay. So 2 blue balls out of total balls is 2 upon probability of one blue ball is 2 upon 9. Total balls is number of total balls is 2 plus 7, which is equal to 9. So 2 blue balls, it is 2 upon 9. If blue balls is there, then one blue ball is there out of 9, then the second ball can come red ball. So it is 7 upon uh, one ball has already came. So it will be 7 upon 8. In second situation, first ball should also be blue and second ball should also be, sorry, 2 upon. See, what I did is, in the first case, We need only one blue ball. So, and we are drawing two balls. Okay. So one blue ball will be there. So it will be 2/9. But second ball will not be blue. So it will be red. And the number of balls is now reduced to 8. So it will be 7/8. And in the second scenario, okay, one has already drawn now. Okay, in the second scenario, first blue ball has been drawn. So it means 2/9. And one blue ball is already been drawn. So number of blue balls is now reduced to one on. And total balls is reduced to 8. So this is the answer. 14/72 plus 2/72, which is 16/7. So cancel it out. 2/, is option number. Okay. Now let's move on to another question. The chance of winning the race by horse A is 1/5 and by horse B is 1/6. What is the probability that the race will be won by A or it is or? So we will add the probability. Okay. Uh, the probability that the race will be won by A. Probability of winning by A is 1/5. Not okay. Probability that the race will won will by B. So it is 1/6. So probability that race will won by A or B. So it is simple. It will be won by A or it will be won by B. Okay. So it is 1/5 plus 1/6. Simple. 11/30 is option number C. Okay. Questions are not that difficult. They are easy. You have to say, you have to just focus what is given. It is or. So when there is or, so we will add. If there was and, if it was saying what is the probability that race will won by A and B. Now, see, generally it is not possible that both the horse will win. Either one will win or two will win. Like A will win or B will win. It is not possible that both are win. So that's why here it was not given to the end. Suppose in that situation, not of the case of race, suppose there is some different situation, then they asked A and B. In that situation, you could have multiplied. So whenever it was and, you should have multiplied. And in case of or, you should add. Okay. Next question. There is a point inside a circle. This is important question. Let me know. And you need to understand it very carefully. Okay. There is a point inside a circle. What is the probability that this point is close to circumference than to the center? Okay, so for solving this question, I need to ask one thing. Suppose this is you and this is your friend. This is your house and this is your friend's house. Okay. So there is a person, suppose your common friend, say C, he wants to visit both of your friends' house and he is standing at a point, say he is standing at a point, we do not know at what point he is, but you know that he is between house of you and your friend, but if you don't know at what point it is standing. Then tell me, when will you say that C is closer to your house? And when will you say that C is closer to your friend's house? In what situation you will say that? How do you know that your friend C is closer to your house? How will you know? Tell me. What is the concept do you use? It is a real life thing that I am asking. How do you conclude that something is closer to your house or something is closer to your friend's house? How do you know? What is the idea? No idea? Okay, let me tell you. So suppose this is the middle point. Okay, middle point. And suppose your friend is standing over here. So if it is to the left of this middle point, then it is closer to your house. And if it is right to the middle point, somewhere after this, then it is close to your friend's house. That's how you conclude. Na? Same concept we will use to solve this. So it is asking probability that this point is closer to the circumference than to the center. Suppose this is the circle. Okay, this is the circle. Then suppose this is the center of the circle. All right. Now this is the radius of the circle. Okay, this is the radius of the circle. And when we will say that some point is closer to circumference and to the circle will be decided after half distance. So it means if it is after this point, then it will be closer to circumference. And if the point is after this, after middle of this radius, then it will be closer to the center. Same concept we will use here. So for that, let me draw another circle. Say this. Okay. So this is the another circle. So whenever the point will lie in this portion, it will be the closer to the center. And whenever the point will lie in this portion, it will be the closer to the circle. This is the same concept we are using that I told you. Okay. So now we can calculate the probability. How? By finding the area of complete circle, that is being our total sample space, and area of this part. Okay. So area of circle, you know that it is pi r square. Suppose r is the radius. Then area of circle is pi r square. Area of circle it is. Okay. And this area of this portion, this is this portion, the shaded portion is area of shaded portion. This is known as basically annulus. Okay, but you do not might be familiar with them. So I am telling area of shaded portion will be this complete area, which is pi r square, minus area of a small circle. What is the area of a small circle? Since the radius is, now the point is at half, now, so radius will be 1 by 2 of original radius. So it will be pi r by 2 square. It means that r square upon 2. So the probability will be favorable, that is pi r square minus pi r square upon 4 divided by pi r. Okay, so pi will cancel out and r square will be cancelled out. It will be 1 minus 1 upon 4 upon 1. So it is 3 upon. All right. So which is option number 3. Okay. Now let's move on to another question. A problem in mathematics is given to 3 students, A, B, and C, and their respective probability of solving the problem is 1 by 2, 1 by 3, and 1 by 4. And the probability the problem is solved. हमको probability, we need to find the probability that the problem has been solved by either one student or two student or all of these. So what I will do, I will simply use the concept of nobody has solved the question. Neither it has been solved by A, neither it has been solved by B, neither it has been solved by C. A and B and C together, they cannot solve the problem. So if it is subtracted by 1, then it will be the problem is solved. Probability of problem is solved. So we know that probability of solving by A is 1 upon 2. So probability of solving by not solving by A is 1 minus 1 upon 2, which is 1 by 2. The probability of solving by B is 1 by 3. So not solving by B by is 1 minus 1 upon 3, which is 2 upon. So for similarly for C, it is 1 minus 1 upon 4, which is 3 upon. Okay. So it means 1 minus 1 upon 2 multiplied by 2 upon 3 multiplied by 3 upon 4. It is 1 minus 6 upon 24. So it is 3 upon 6. Okay. Two questions was easy. So in the probability, I already told you there will not be question of too much length. There always be 1 or 2 liner question, 3 liner at most. Okay. Next question. Few more questions, then we are done. Okay. If A and B are any two events such that P A union B is 3 upon 4, A intersection B is 1 upon 4, A naught 2 upon 3, where A naught stands for complementary. What is the probability value of B? Okay, so P of A naught is given to be 2 upon 3. It means that probability of A is equal to 1 minus 2 upon 3, which is 1. Okay, so now you have probability of A union B is probability of A plus probability of B minus probability of A intersection B. So now A union B is 3 upon 4. Probability of A is 1 upon 3. Probability of B is probability of B we need to find. Probability of A intersection B is 1 minus 4. The probability of B is what? It will be 3 upon 4 plus 1 upon 4 minus 1 upon 3. So it is 2 upon 4 minus 1 upon 3, which is 12. 6 minus 4 is 2 upon 12, is 1 upon, this is 6, 6 minus 3, 6 minus 4. Okay, okay. Let me see once if I have made some mistake in the calculation. So it is 3 upon 4. A union B is 3 upon 4. Probability of A is 1 by 3. Okay, it is correct. Probability of B we need to find. And probability of A intersection is given to be 1 upon 4. I add this, which is 4 upon 4. Sorry, sorry. It is 4 upon 4 na? Minus 1 upon 3. So it is 1 minus 1 upon. So it is 2 upon. Okay. 3 plus 1 is 4 na? So it is 4, which is option number B. All right. Next, what is the probability of getting a sum 7 with 2 dice? 2 dice are thrown and they are asking for the sum to be 7. So when the sum will be 7, it is in the case of 1, 6, 6, 1, 2, 5, and 5, 2. Okay. 3, 4, and 4, 3. Is there any other possibility? No. These are the only possibility when sum will be 7. So number of elements in sample space when there are 2 dice is 6 raised to power 2, which is 36. And we have favorable outcomes. Number of favorable outcomes is how much? 1, 2, 3, 4, 5, 6 only. Okay. In case of 2 dice, it can be 1, 6, 6, 1, 2, 5, 5, 2, 3, 4, or 4, 3. So for required probability is favorable outcomes upon total outcomes. So it is 6 upon 36, which is 1. Okay. So option number A is correct. So these are the possibilities of getting sum as 7. There is no other possibility. All right. Option number A is correct. Next question. In a relay race, 6 teams participated, named ABC to F. What is the probability that ABC finish first, second, and third respectively? A will come first, B will come second, C will come first. It means that A will come first and B will come second and C will come third. It is not or case, okay? It is and case, okay? So A will come first if there are 6 teams now. So if A will come first, it means that probability of winning the race by A is 1 upon 6. Now one person has already won. So only 5% is remaining. So probability that B will come at second place in that situation is only 5% are remaining. So it will be 1 upon 5. Similarly, for third case, now 2% has already removed. 4% is remaining. So it will be 1 upon 4 then. Let's multiply by together and you will get the answer. It is 120. Okay. Next question. Let's check the answer. A box contains 3 white and 2 black balls. 2 balls are drawn at random, one after the other. If balls are not placed, what is the probability that both the balls are black? So you can use either permutation combination to this or y simply. So if you use the permutation combination, it is same way two balls are drawn one after the other, and it is asking for the probability that both the balls are black. So if first ball is black, it has been one out of three. Now one ball is two out of one, not one out of two out of one, because there are only two black balls. Okay, three white balls. In second situation, black ball is being removed. Now it has been not replaced in the in that box again. So it is now out. So how many black balls are remaining in the box? It is one. And how many need to select out of that? One, because it is asking for both the black balls. And how many total balls were there? Five. And we are bringing out two from that. Okay. So how much it will be? So it will be 2 into 1 upon 5 into 4 in, and divide by 2, which will come as of. It will be 2 to the 2 to the, it is 1 upon 5. Option number B will be correct here. Okay. So now let's move on to another question. Two men hit a target with probability 1 upon 2 and 1 upon 3. What is the probability that exactly one of them hits the target? Suppose this is the target that is being hit by persons A and B. If this will hit the target, its probability will be 1 upon 2. If this will hit the target, its probability is 1 upon 3. The probability of not hitting by 1, it is 1 minus 1 upon 2, which is 1 upon 2. Probability of not hitting by B, it is 1 minus 1 upon 3, which is 2 upon 3. So it is saying exactly one of them will hit. If A hits, then B will not hit. And if B hits, then A will not hit. Okay. So there are two situations, this situation or this situation. Okay. So in first case, we know that it is 1 by 2 and it is 2 by 3. And in this situation, it is 1 by 3 and it is 1 by 2. So it is 2 upon 6 plus 1 upon 6, which is 3 upon 6, which is 1 by 2. So option number A is correct. Okay. Okay, now we have the last question. Okay, so there are four letters and four directed envelopes. These four letters are randomly inserted into four envelopes. What is the probability that the letters are inserted into corresponding envelopes? What it is mean, let me tell you. There are four letters, say A, B, C, D. Four letters and four envelopes, say A, B, and C. And the directed envelopes means there is on the envelopes it is written A, B, C, and D. And the suppose someone has blindfolded and he asks to put all the letters A, B, C, D in the box mentioned as A, B, C, D. Now he can put in he can put A in A as well, he can put A in B as well, in C as well, or in D as well. Similarly, uh, B can be put in A or B or C or D, or C can be put in A, B or C, D, or D can be put in A, B, C, D. But it is asking for the probability that the letter inserted into corresponding envelopes means A in A, B in B, C in C, and D in D. So in first situation, A is put in A. It means that there are four envelopes and A must be put one out of four. So it is 1 upon 4. And it is situation of and na, A and B and C and D all in their corresponding. So now envelopes are how much remaining? Three envelopes. And how much is B? It is 1. So 1 out of 3. Now two envelopes are remaining and two envelopes are there, two letters. So 1 out of 2, it means 1 upon 2 now. And now only D is remaining, so 1 upon 1. So it is simply 4, 3 are 12, 2 are 24. So it was very easy. Okay. A and B and C. So this is how we do. So this probability of A multiplied by probability of B multiplied by probability of C multiplied by probability of D. All are multiplied together. So it is 1 upon 2. That's all. Let's get the answer. It is option number C. committee of 2% is continued to form two men's and two women's, what is the probability that the committee will have only women? So this you can do. You can let me tell you what it will be like. 0 men and 2 women. Okay. And how many total persons? 4 are there. So you can solve it. It will be 1. It will be 1. And it will be 6. So it will be 1 upon 6. So you can do this question by yourself. Okay. This is not tough. So these are all questions that we did today. And probability is easy. Questions, if they will come like this only. I have covered all the type of question that can hardly come in exam. Or they are not that tough. They are only one-liner, two-liner, or simple questions. You just need practice. Okay, more the practice you will do, more the questions you can do. So that's all for today's class. If you have any doubt, you can contact me or you can ask whenever you want. I will tell you.